See this question, which of the following statements are not true? So they have given some statements about distributive lattices and they are asking about true or false. So it is a very important example, try to understand this. So we have already seen two examples, L1 star and L2 star. So if any lattice contains within itself a sublattice like this, right, or a lattice like this, right, then we know that it is not going to be a distributive lattice. So if you, from now on, if you want to verify whether a lattice is going to be a distributive lattice or not, instead of verifying that distributive law for every three elements, it is going to be very cumbersome. It is easier to see that if it contains a sublattice of this form which is isomorphic to this one or this one, if a lattice contains sublattice which is identical, which is isomorphic either to this one or this one, you can directly say that it is not a distributive lattice, right? If the given lattice does not contain this structure isomorphic, any sublattice which is isomorphic to these structures, you can say that it is distributive, no other rule, right? And some other way of discarding whether a distributive a lattice as not distributive is try to find out an element which is having more than one complements, but then that complementation method might not work always, so this is the best way. So whichever way you feel comfortable, go with that. Okay, if an element is having more than one complement, you can directly discard the lattice as not distributive, otherwise you can use this one. Okay, now say this, a lattice with 4 or fewer elements is distributive. So they are saying that if you have only 4 or few elements, so 1, 2, 3, 4, if you have either one element or two elements or three elements or four elements in the lattice, they are saying that it is distributive. It is true. Why? Because if you have only 4 elements in a lattice, then definitely it cannot contain these 5 elements, either these 5 elements or these 5 elements, right? Therefore, if a lattice should fail to be distributive lattice, it should at least have 5 elements. If it is having 4 or less, it is definitely distributive. Therefore, it is true. Next one is, every totally ordered set is a distributive lattice. So they are saying that if you have a totally ordered set, which means a chain, isn't it? A totally ordered set is a chain. So every totally ordered set is a distributive lattice. So if you have a chain like this, then inside a chain there is no way either this one or this one will be present, isn't it? Therefore, since a chain does not contain within itself any sublattice which is isomorphic to this one or this one, we can say that every chain is a distributive lattice, right? So I'm just using these two rules to prove many points here. Next one is, every sublattice of a distributive lattice is also distributive. Now observe this, they are already saying that it is a distributive lattice. If a distributive lattice is given, what can you say about it? In a distributive lattice, there will be no sublattice which is isomorphic to either this one or this one, right? And therefore, there will be no sublattice which will be isomorphic to this one or this one. I think, are you getting this point? See, already given that a lattice is distributive. What does it mean? There is no sublattice present in it which is isomorphic to this one or this one, isn't it? Now if you take any other sublattice, it will not be isomorphic to this one or this one, or even they will not contain any structure isomorphic to this one or this one. Okay, so it is becoming difficult to prove it. So let me go step by step. See the point number C. Every sublattice of a distributive lattice is also distributive, right? So what does it mean? Let us say it is false. So if it is false, then what does it mean? The sublattice of a distributive lattice is not distributive, which means if I have a lattice, then there must be a sublattice which is not distributive. Then what does it mean? Then this particular sublattice should contain within itself either L1 star or L2 star, right? And if this particular structure is a sublattice in this structure, in this sublattice, definitely this is a sublattice in the original lattice as well. Therefore original lattice will not be distributive, but then it is given that it is already distributive, therefore the sublattice is also a distributive lattice. Are you getting this? See, what they are saying is, if you have a distributive lattice, if you take any sublattice, then that is also a distributive lattice. That is what they are saying. Now how am I trying to prove it is, let us say it is false, which means if there is a distributive lattice, there might be a sublattice which is not distributive. Now why will this sublattice be not distributive? Because it might contain a structure which is isomorphic to L1 star or L2 star. Now this structure is already present as a sublattice in this sublattice. If it is a sublattice in this sublattice, then definitely it is a sublattice in the original lattice. Now what does it prove? That the original lattice is containing L1 star. What does that mean? That the original lattice is not distributive, but it is given that original lattice is distributive, which means by contradiction we can say that every sublattice of a distributive lattice is distributive. Got it? And next one is, every distributive lattice, okay, this is also true, every distributive lattice is a bounded lattice. So they are saying that every distributive lattice has to be bounded. Is it true? Now you can give me a chain. Okay, there is no relation between distributive lattice and a complemented lattice. So actually distributed lattice is different and a complemented lattice is different, and distributed lattice is different and a bounded lattice is different. So we need not include bounded lattice definition in distributive lattice. Actually we wanted a lattice to be bounded only to define the complements, and if you don't want the complements, we need not care whether a lattice is bounded or not. So if a lattice has to be distributive, the important rule is every three elements of the lattice should follow the distributive law. Otherwise it is not going to be distributive. So a lattice is going to be distributive only if it obeys the distributive law, otherwise it is not going to obey. There is no relation between bounded and then the distributed law, or bounded and complements, or distributed and complements, all are independent concepts. So I'll just give you an example of a unbounded lattice which is distributive. For example, if I take set of all natural numbers 1 2 3 4 so on, and if I define less than or equal to, the relation on that, then this is a poset which is going to be a lattice, right? Okay, so it is definitely a poset, right? And it is a lattice as well. We know that, we have already seen it. But then if you see this lattice, it is not bounded, it is a kind of chain. You will have 1 2 3 4 so on infinity. It is not bounded, but still it is distributive because it is a chain, and a chain will not contain either this one or this one as sublattices. Therefore we can say that this chain is unbounded, which is distributive, and so every distributive lattice need not be bounded. So it is false, which means we have a chain which is unbounded, which is distributive, right? So this is an example. So this fourth point is false. So this is very important example, because in this one we have discussed about all the properties, almost all the properties of distributive lattice. Okay, so go through this once again. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.